All right, folks, you ready to get more complicated with formula weight? But, honestly, I don't really think that this is any more complicated than our previous examples. The numbers typically kind of throw people for a loop a little bit, but I'm going to show you kind of a quick trick to hopefully let you understand this concept a little bit better. So let's say that I have to calculate the formula weight of a compound. And this compound, this time, is H4, but there's a parentheses around it, and there's a 2 down below in that parentheses, and then we have SO4, and we need to calculate the formula weight for this compound. Well, this one is a little more complicated, just due to the subscripts and the parentheses. It throws people for a loop for sometimes. Don't know why, but it's as easy as the other ones. So I'll first want to tell you what this basically is talking about. It looks like we have 2 of these NH4 groups. That is what that is saying. So if you want to break this down a little bit better, you can write NH4, NH4, SO4. And then all of a sudden you get rid of the parentheses, and it goes back to the traditional examples that we did in the last video, right? You write down the nitrogen because you know it's present. You write down the hydrogens because you know that they're there. You write down the sulfur, and you write down the oxygen. That's all that it means, people. But we get lazy, and we don't really like to write that out, especially if there's more than one set of parentheses, right? But that's what that parentheses means. It's talking about a group that needs to stay together, right? And this group that is staying together is an NH4 group. And there's 2 of those groups that are hanging out in this molecule. So here's my first group. There's my second group, and then I have my SO4 that follows here at the very end. If that's the way that you need to do formula weight, then do it that way. No one's going to scold you or get mad at you because you'll get the right answer in the end. There's no difference. So this is one of the ways that we can do it, right? And we're just going to keep it this way just for a second, and then I'm going to kind of clear up and maybe give you a shortcut in a way. But here's my nitrogens, right? And I need the weight for nitrogen. We've not done that one yet, so I'm going to pull up the periodic table. I'm going to find nitrogen. It's right here, 14.0067. So I'm going to round that to 14.01. Hydrogen we've done before, 1.01. Sulfur we haven't done yet. So I'll go to the periodic table. I'll find sulfur, that's in the chalcogen group, not halogen, chalcogen. Got to sound like a Russian. All right, so 16, molecular weight, 32.065. So I'm going to round that off, and it's going to round to 32.07. So that's the sulfur. And then the oxygen number, we've done that one before as well. That's 16. All right, so now I'll go to my formula just like I've done in all the other examples, and I need to count out how many that I've got. All right, well, if I go by what I just done here, there's 2 nitrogens in total. So I'm going to multiply by 2. If I go with my hydrogen, there's 4 from there and 4 from there, and that's it. So there's a total of 8. If I look at the sulfur, there's only 1 of those, right? Because this 4 goes directly to the oxygen, not to the sulfur. So there's just 1. And then finally, there's 4 of the oxygens. So that's a total of 16 times 4. Okay, so now I do the math that's associated with each one. I break it down by the steps. 14.01 times 2 is 28.02. 1.01 times 8 is 8.08. 32.07 times 1, 32.07. And then finally, 16 times 4 is going to be 64. 68, sorry. No, 64, that's right. Brain fart. All right, so now I'm going to add them all up. So I'll bring my calculator. 28. Well, if it works, let's try this again. 28.02 plus 8.08 plus 32.07 plus 64. So I get 132.17. 132.17 grams per mole. So just because the parentheses was there does not make these problems more complicated. At least it shouldn't, right? Especially if you do it kind of like what I've done here. This normally helps people visually see it a little bit better. However, what if you didn't want to do that? I'll show you how normal people do it. When you get comfortable with formula weight, this is what goes on. So you do it just like before. Hey, I've got nitrogen, I've got hydrogen, I've got sulfur, I've got oxygen. I'm going to find the weights from the periodic table. So 14.01 for nitrogen, 1.01 for hydrogen, 32.07 for sulfur, and 16 for oxygen. And now I need to bring in the multiplier. How many do I have? Well, this 2 goes to everything that's in the parentheses, right? So there is 1 nitrogen in the parentheses, you double it. 1 times 2 is 2. There's 4 hydrogens in the parentheses, so in this case you double it. So 4 times 2 is going to be 8. There's 1 sulfur, and then there's 4 oxygen. And there you go. It's the same thing that we did up before. You just have to remember those are multipliers, right? So there's a understood 1 that's after the nitrogen. So 1 times 2 is 2. And then the hydrogen has a 4 there. Well, there's a 2 on the outside of the parentheses. So 4 times 2 is 8. That's how you solve these problems a little bit quicker. If you don't like that, though, in the beginning, then by all means, write it out this way. Do it like we did before. No big deal. You're going to get the same answer no matter what. Okay? So there's an example of one that uses parentheses. So let's do another one just to make sure that you feel comfortable with that, and we'll keep chugging along. So this time we're going to look at Ca3 parentheses PO4 parentheses 2. All right, so I do this the same way, and this time I'm going to write down how you would do this if you didn't like the shortcut, but we're going to do it by the shortcut method. Okay, I want you to get away from writing these down if you can. It's not wrong, but it's going to take a little bit longer, and I want you to be better than that. Okay, so if you're uncomfortable with the parentheses, this 2 means you have 2 of those groups. So we have Ca3, and then we have a PO4 group. There's my first one. And then another PO4 group. There's my second, right? Then you can go from here, do the formula weights just like we've done before. Count them all out, multiply by the number, get the formula weights, you got it. However, we're going to do the shortcut method here. That's how I want you to follow me this time. So we've got calcium, we've got phosphorus, and we have oxygen. So we need to pull the weights for each one of these, right? So we need to do calcium first. Calcium is an alkaline earth metal, and this is in period 4. And calcium up here at the top is 40.078. So we need to round this off to 40.08. So that's the weight that I'll use for calcium, 40.08. All right, now we look at phosphorus. I'm going to pull the table up again. Phosphorus, where's phosphorus? It's over here to the right-hand side of the table, and it's spot number 15. So the weight for phosphorus is 30.97696. I'm going to round it off. So that's 30.98. So that's the number that I'll use there. 30.98. And then for oxygen, well, we know what that one is now. We've used it so many times. That's going to be a 16. Now I need to bring in the multipliers, right? How many of these do I have? Well, it looks like I've got 3 calciums, so I multiply that number by 3. And the phosphorus here in this parentheses, there's a 1 that's understood to be there, right? So remember what the small subscript out of the parentheses means. So this is 1 times 2, which is going to be a total of 2. And then oxygen, that's 4 in the parentheses times 2, because we're doubling it, right? So 4 times 2 is going to be a total of 8. If you go down here and look at this piece that we did, 3 calcium, I get 1 phosphorus, 2 phosphorus. We did it that way. And then I receive 4 O's here and 4 O's there, and that gives me a total of 8. Now, I'm not going to do each individual one of these. Okay, we're going to start learning how to skip some steps here, and I'm just going to kind of plug them into my calculator as I see fit. So here I've got a scientific version of the calculator up, and when you pull up the scientific version of the calculator, you should be able to access these parentheses and those types of things in the calculator if you're using the computer, or if you're using a normal like TI graphing calculator, you do the same thing too, just to be safe. Don't skip any steps at all. So I'm going to open the parentheses up first. So I click that button, it opens it up, and I'll do 40.08 times 3, and I'm going to close that parentheses up. So that's 124.24. Well, I'm going to add to that parentheses 30.98, and there's 2 of those. So I multiply by 2, and I close that parentheses up. And then I'm going to add to that, parentheses opened, 16 times 8, close the parentheses, that's 128, that's what that number represents, but now I have to hit enter. So that way it will add all 3 of those together. So look on my computer screen, right? This is how it should look in your TI graphing calculator as well if you're using it. Parentheses 40.08 times 3, because that's the first step that needs to be done separately. Then the second step is 30.98 times 2, that's done separately. And then the third step is 16 times 8, that's done separately. So I add them all up, and the answer is 310.20. So 310.20 grams per mole is the formula weight for the calcium phosphate, Ca3PO42. All right. Now, let's do one more example. And this example is going to involve something called a hydrate. So let's say that we have a hydrate of CaSO4. No, let's do something different. Let's do copper sulfate instead with 6 H2Os after it. Bigger formula, but you don't treat it any differently. Okay, so I get copper sulfate, 6 H2O, copper 2 sulfate here. All right, so I'm going to come over to the side. The only difference here is this tag-along piece. We've not really seen this dot before, and then I see some of the water molecules that are hanging out here. So I know that I have copper, I need the weight for that one. I know there's sulfur, I need the weight of that one. I know there's oxygen, so I'll need the weight of that one. Then we go into the water complex that's down here. So I know there's hydrogen that's going to be involved, and now I know there's more oxygen involved too, so I'm just going to kind of add all of those pieces together. So these are the only atoms that we have to worry with from the table. Now, what does this molecule mean? Well, this means that you have copper sulfate that's kind of hanging out in the center, and this is called a hydrate, Hydrate, very common in a laboratory environment. A lot of times we do not have what we call anhydrous compounds, meaning no water associated with them. A lot of the times when we order chemical, there's water associated with them. Water loves to hang out with these compounds, and they don't mind it. So it's not going to do anything bad for a lot of these, and that's okay. We just have to include that into the formula weight calculation. Well, copper 2 sulfate, think of it as a landlord that has a couple of apartments that he would like to rent. He can only take a certain number of renters before he gets full. Copper sulfate's the same way with water. He can only take in a couple of water molecules before he gets full. How many? Well, this is telling you 6 of them. So there's actually a water molecule here, and maybe a second one, and maybe a third one, and maybe a fourth one, and maybe a fifth one, and maybe a sixth one, right? So there are my 6 water molecules. Here's 1, there's 2, there's 3, there's 4, there's 5, and there's 6. And they're all hanging around copper sulfate. They're not really permanently attached. It's just an association. That's all that there is. They're just kind of hanging out for a while. If I put a little bit of heat on these guys, then I can drive that water off and I can get an anhydrous compound maybe because of that. But I can drive the water off if I don't need it there. But it's part of the formula. It hangs out. Copper sulfate loves it to be around, and because of that I have to include it in the formula weight calculation. So if you wanted to do it the long way, this is how you would do it, and you would count the number of coppers, count the number of sulfurs, count the number of total oxygens, not just from this one, but all of the waters as well, and then count the number of hydrogens in every single water across the board. But we're going to do it a shortcut way. So I need the periodic table. In that periodic table, I need to find copper. If I try to find copper on the table, I'm going to find it at number 29. And that copper weighs 63.546 or 63.55. All right, so 63.55. My next one's sulfur. We've done that one before already. That's 32.07. The next one's oxygen. I don't even need to pull that one up for you because you've used it so many times. That's number 16. And then hydrogen's going to be the same way. That's 1.01. So now we bring in the multipliers. Well, I see only 1 copper, right? That's it. It's understood to be a 1. It's not written, but it's understood to be there. So that's 63.55. All right, if I take a look at the sulfurs, well, there's 1 sulfur that's here. I don't really see sulfur anywhere else, so that's going to be multiplied by 1. So 32.07. Now take a look at the oxygens. There's 4 from here. And there's another oxygen in the water molecule, but this big fat 6 that's out in front, that 6 goes to everything that follows it in that formula. There's 6 of these water molecules in total, right? So there's 4 from the copper sulfate piece, and then there's going to be another 6 times 1, which is 6 from the oxygen. So 6 plus 4 is a total of 10. So this is going to be 160. Now, if you don't believe me, go down here and count them, right? Look at this picture. There's 4 oxygens in the center, and then there's 5, and then 6, then 7, then 8, then 9, and then 10. So 6 from the water, because there's 6 of them in total, and 4 from the oxygen gives you a total of 10. And then finally the hydrogen, right? There's no hydrogen here with the copper sulfate. It's only coming from the water. So that's 6 times 2, which is a total of 12. So that's 12.12. And I add them all up. Again, if you don't believe me, there's going to be 2 from here. Another 2, which is a total of 4. Another 2 brings me to 6. Another 2 brings me to 8. Another 2 brings me to 10. And another 2 brings me to 12. So now I'm going to take my calculator and I'm going to add them all up. So 63.55, 32.07, 160, and 12.12 gives me a total of 267.74. 267.74 gram per mole. All right? So that's how we do formula weights. That's how we do formula weights for simple compounds. That's how we do them with compounds that have parentheses. That's how we do them with hydrates. that have water that's associated with them. All right, so I think if you follow these rules, that should be good enough to get you a start on the very first assignment module of the 150 class. And this very first assignment is nothing more than just solving for formula weights of compounds. That's all that we're doing. Keep in mind, take your formula weights to 2 decimals, round them off. In the assignment, they're going to give you some wiggle room. So let's say I report 267.72 instead of 267.74. It's probably going to count that correct. You're close enough. So we're going to give you a small window of opportunity to give us a right answer, because depending on how you round and depending on the numbers that's actually on the periodic table, you might get a slightly different number. It won't be a big difference, but you might get a slightly different number, and that's okay, and we understand that. So, in the next section of this module, there's going to be nothing but one problem after another problem after another problem for formula weight. I want you to attempt these problems, solve for formula weights, and then when we get to that point that we'll feel a little bit better about the math, we'll go to the next lecture topic.